In this video I'm going to talk about a rail system that we built. I'm going to talk about first the basics. First part of the video I'm just going to talk about the basics of it and how it came about, and then in the second part of the video I'm going to talk about how we made it and some of the challenges that we had in making it. So if you decide to make one of these yourself or something similar, that you can understand some of the challenges that we faced when building it. What we've got here is a rail system that was made much like a CNC 3D printer or a laser cutter. And we got the idea first from one of my employees, suggested that we make a rail system or an electronic easel. I was showed some videos on the interwebs that showed that you could take a Nintendo 64 controller like this and program it, and that maybe we could make it work like that. And thus began the project of trying to build out this rail system that we've got here now and working. And I'll show you how it works real quick. What we've got here is a Nintendo 64 controller, and you can take it and move it to the left, move your painting about, you can move it up, back to the left, and you can move your paintings around the way that you need to move them in order to position them in front of the camera. We decided that we wanted to move artwork about instead of moving the camera about. We want the camera to stay parallel to the artwork, and we want the camera to stay still so there's no movement in the shots that are being taken. And thus began the project, or the idea of how to build this out. Now, how do we build it out? We built this out, we started building this out using parts from Open Build's parts store, and it was the Open Build store online that sort of set us on the track of finding all the parts and the things that we needed to do this, including these rails. And this is one of the more difficult parts here. The rails are 9 feet by 9 feet tall, so 9 feet wide by 9 feet tall, and the horizontal movement is on a trolley here. And so we can set the paintings top and bottom. We've got little pins right here that we can put in front of the paintings to keep them from falling out. Normally we don't need them, but we find that sometimes they're very helpful, especially with very expensive paintings and things that we don't want to fall down. This right here is run with motors. They're all run with motors. But this right here is on a belt system horizontally. That part was very easy. So you can see you've got a little belt here with grooves, and when you use the controller it will move the painting left and right. This doesn't have any what's called a stay current in the motor to hold it in place, because it doesn't need to be held in place because there's no way for it to fall down horizontally. So we left it like this so that it's free floating when you're not using it with the controller, so that you can come in here and move things about a little bit left and right by hand. But this rail right here vertically is controlled with 2 motors at the bottom here. These are NEMA 23 motors. They are high torque motors, and this enables the bar to hold the weight and not move about. So we can put pretty heavy paintings on this and it won't move at all. But we needed the high torque motors. We couldn't use just standard motors for the vertical lift because we really needed to hold some weight, and we needed to stay in place when we're not controlling it. There are also counterbalances here. Now, the thing I can say about the counterbalances is they would be more free floating and have no resistance if we didn't have a lot of angles. But really we needed, because of the setup, we needed to put the counterbalances over here on this wall, and that means we needed to run cables from each sides of the bars here, up, over, across, and down, and that actually adds a little bit of tension to the setup so that it's not as free-flowing as a counterbalance system can be. I'm going to show you an example with our camera here. This camera right here is on a FOBA tripod, and it is very, very free-flowing. But the counterbalance is inside here and doesn't have any resistance because the pulley just goes right over the top and back down. These we really needed them to be here on the wall because we couldn't just do a pulley and run it on the back side of the wall. We don't have access to. The good side of the tension, if you're to try to do something on your own, the good side of the tension is that even without the motors, sometimes having just a little bit of tension in this bar here we found to be useful. It helps hold it in place when the amount of weight on the counterbalance isn't exact, and so that's actually a little bit of an advantage. The boxes here for the counterbalances, we just built simple boxes, and inside the boxes we just have weights. These are extra diving weights that we bought from a dive shop. These aren't really used much anymore. They're old lead weights, and they have better weights now. You can still buy these used at pretty much any dive shop. It's called the dive shop and ask for lead weights. We found that to be the best thing to use, and we've got a stack of lead weights here that we can choose from. We've got a few here and some over on the other side, and we can adjust the weights as needed, both for the top and the bottom. In terms of adjusting the bar so that it stays level, on a CNC router or a laser printer, once your bars are in place, they're generally going to always be parallel. These are 9-foot bars, and they've actually got a little bit of play in them. So we need to use these weights and these lines on each side to keep it in adjustment, and the way that we've kept it in adjustment is using these adjustment screws right here. We've got them on both boxes, and we're finding that these are just super helpful. It's really, really easy to just take one of these and give it a couple turns and tweak it, and this bar, if it's even, you know, 1/4 inch or 1/2 inch off, it'll straighten itself out very quickly. When we first started, I thought we wanted a very, very light bar, and you can see that I've got one bar hooked to another one here at the top, so that there are 2 bars. And the reason is we found out that when we first built it, we wanted to keep it as light as possible on the top, but we found out that we actually needed some weight behind this. It actually has to have some weight for it to work, and sit and pinch the paintings in there. You'd be surprised. So not only did we need to add the bar here, but up in here there is a little 1-pound lead weight that we've put in there on each side to add weight to the bar, and then we counterbalance it over here. We find that the weight in the counterbalance and the bar playing against each other really stabilizes this and makes it usable. When we started off building the bars, we only had one bar here on each side, and we found that there was too much play. With a 9-foot system like this, there was just too much play, and so what we really needed were 2 sets of bars on each side with gantry plates here, and find that 2 gantry plates and 2 V-bars on each side in order to hold this really keeps it stable, and that's what we did there. One of the biggest challenges we had, I would say, is the vertical, because with most CNC systems, 3D printers, etc., you're really not worried about much weight. The only weight that you're really carrying is the head that's either doing the 3D printing, or your CNC router, the router bit, or the laser head. With this, we've got quite a bit, it's carrying quite a bit of weight. It's carrying it up and down. We went through several iterations, as you do with any engineering project, and we found that the belts weren't working. I tried different belts, I tried different gears, and that just was not enough. And what we ended up doing is using roller chain. This is much like a bicycle chain, only the chain that we've got here is a little bit smaller. This is called number 25 roller chain. So roller chain and sprockets, and what we did was put sprockets on the motor rather than gears for a belt, and this is holding in place just beautifully. Now, to keep the belt, or to keep the chain tight and adjusted, we've got two ways to do that. One, we've got an adjustment plate up top, and we can adjust it there simply by screwing that top plate, and it tightens up. But we've also got these adjustment things here. I'm sure in the comments people are going to tell me it has a name, and that I should know it if I'm an engineer. But we put them here on the chains as well. So if on one side or the other of the chain starts to get a little bit loose, we can use these right here to very easily tighten it. And honestly, it's just like tightening a bicycle chain on your bike. It doesn't take much at all to make this nice and taut. And this is not slipping at all. At this point, we've had a good 50 pounds on this, and you can just I'm not going to break it, but we can put a lot of weight on that, and these motors hold very, very well. Another challenge we had with the motors, and I saw this in forums online as well on how to control these motors, is that the motors were getting very, very hot. They were getting so hot that they were hard to touch. And what we found is there are two things. One, you can turn the current down. And so we turned the current inside the Arduino software to be half current, and that helped them quite a bit. That helped them with the vertical motors enough. And these now, I can leave this on for a good hour or 2 hours, it doesn't matter, and you can wrap your hand around it. It's just barely warm, so it's just fine. For the horizontal movement on the motor here, what you can do when you're programming these is you can turn what's called the hold current, which holds the motor in place, because if you've got a CNC router or a laser cutter or whatever, you don't want that head to move at all on its own. It cannot move on its own. And here, we don't care on the horizontal one. Sometimes we actually want to walk up when we're taking paintings on and off of this and just grab it and move it around with our hand. And so the hold current on the horizontal motor is completely turned off when it's not actually in use. And that together keeps all the motors very, very cool, and everything is running just great. We're able to take the paintings and move them about and keep them right in the middle of these lights. The lights are at 45-degree angles here, so you've got perfect lighting in this one area right here. If you have to do multi-shot now, which we're doing more and more of, this is absolutely fantastic, because we can set the camera up and we can move it, move the artwork using a Nintendo 64 controller over by the computer. We can sit at the computer and do tethered capture and move this about as we're doing the tethered capture, and it's easier for us, it's safer for the painting, and it's just saving us quite a bit of time. The top bar is just free floating, so it follows the movement of your bottom bar, and that's actually what we want. We don't want to complicate it with extra motors, and just the weight of the bar itself keeps whatever you've got here pinched in and working. There are times when we don't want to use this, we want to just put something on the wall, and when we want to do that, we can just take this and move it aside, or we can take the bars, raise them all the way to the top, all the way to the bottom. What we have here is a magnetic wall. We've used magnetic paint and chalk paint over the top of that for this wall, and that enables us to take paper and put it onto the wall with magnets. All together with all of this, what we've got is a very wonderful art capture system. That's how we built it. I'm going to show you in just a second. I'm going to show you the Arduino setup that we made. And can you think of anything else? Now I'm going to walk over to the computer here where we do our art capture, and when I need to move that about, what I do is, while I'm standing over here, just move the painting about. Super convenient. Now for the controller. Okay. So to control all of this, what we had to do was make an Arduino setup, and here's your Arduino controller right here. But we needed a power supply and controllers for each of the motors. So here we've got a power supply that's controlling each of the 3 motors, and these are the motor controllers here that you need to buy to control them, and everything is hooked up. What we did was took an old PC that we were getting ready to recycle, and we pulled all the guts out of it, put in a wood board here, and painted it black so that we could mount all this stuff onto the board, put it into the PC, and now there it is. When it's in use, we can just take this and put the cover on, and it looks really slick, and people think it's actually a computer, but it's not. It is in fact our controller for the rail system. All of this is controlled just by a power switch over here. We can turn on and off, and all this turns on and off. And that is how we did it in a nutshell.
What problems did you run into when doing the Arduino?
In terms of programming all this with the Arduino, the problems that we ran into were first how to control the Nintendo 64 controller. Once we found the API for that, that was easy to handle. The controllers here can be set to 12 volt or 24 volt. We needed to set those for 12. Didn't figure that out right away. I would say one of the biggest problems that we had, and I mentioned it earlier, is that when we first started programming this, the motors were heating up. And they seem abnormally hot, and we found some threads on the internet with other people having heat problems with these motors, and we quickly resolved that. In terms of programming it, I am not an Arduino programmer, and so I went out onto Upwork.com and I found a very wonderful Arduino programmer, electrical engineer, and he is the one that designed the schematic for this and wrote the software for it, and we did the software in increments. I would say that was the biggest challenge. One of our biggest challenges was just finding the help that we needed in order to do this. If you're an Arduino programmer yourself, that's great, but I imagine a lot of people that want to build a system like this aren't programmers and will need some assistance. To that end, in this video, in the comments, I am putting a link to the files that we have for this, and there will be a zip file there you can download, and inside that zip file there will be the Arduino code to run this with a Nintendo 64 controller, the schematic that we used to put all this together, and a PDF parts list. Now the parts list isn't going to match what you need exactly, but it'll give you a great idea as to the kind of things that you need as you go to MacGyver your own system based on this, if that's what you want to do.
What if I didn't want the motors? Could I just have the rail system as the rail system?
Good question. If you want to build this out without the motors, you can certainly do that. And yes, you can build this without the motors and make it a manual system. In fact, we use this manually. Use this manually for a good month and a half while we were figuring out the programming, while we were perfecting all the weights and counterbalances, etc. And you can do that. One thing we found was very, very helpful was these clips. So for example, if you're an artist and you just want to set up the rails like this and not do any motors at all because that's expensive and complicated, you can do that. And we found that these clips right here, we would just take them, put them like that, and your rail would stay in place. So if you were an artist and wanted to paint like this, for example, you could do that, and then when you wanted, move it down. As long as your weights are very similar in your counterbalances there, then you should have no problem doing that. And as I said, we used this for a good month and a half like that, and it was super convenient. We fell in love with it before we even got the motors going. That, I think, summarizes what we've made here. This is our new rail system, and thank you for watching our video. We hope you enjoyed this. We hope it's helpful. And also, as I said, if you look in the comments, there is a link to download the files so you can get our parts list, the Arduino code, and the schematics for building it out if you want to build one yourself. If you have any comments, questions, please leave them in the comments and I'll try and respond. Thank you.